We are being asked to factor by grouping using the area model, and you will notice that this is the first time that we are going to be using more than one variable. So I see x's, w's, k's, and y's. It's the same exact process, so please do not get intimidated by the multiple variables. So the very first thing that we need to do is we need to put it into standard form. When you have multiple variables, you need to consider the weight of both variables. So he has an exponent of a 1, he also has an exponent of a 1. Which means this weight is 2. He's 1 and 2, which meant his weight is 3. Weight is 2, and this weight is 3. Because these two have a weight of 3, these two battle it out to figure out who is technically going to be in the front of standard form. Both of the 2's actually come on the k's. So the letter that tells us the variable that makes the choice is either the x or the y, and we go alphabetical. So that meant that this goes first because x comes before y. So positive 49, xk squared goes first, and then we're going to have the minus 21 yk squared next. These both have a w, which meant that x is the thing that's going to decide it. And again, x has the alphabet first, so this is a positive 56xw. That's a minus 24yw. So we went ahead and we put it into standard form as best as we could. Now we're going to see if there is a GCF. Since there are 4 terms, there are going to be 4 lists. 49 is 7 times 7. If there was one x and at k squared, meant there were 2 of them. The only number allowed to be negative is a negative 1. 21 is 3 and 7. That was 1 y and 2 k's. 56 is 2 times 2 times 2 times 7. It had 1 x and 1 w. The only number allowed to be negative is a 1. 24 is 2 times 2 times 2 times 3, and we have a y and a w. So my GCF, what do all 4 lists have in common? So looking at the numbers, they do not have any numbers in common. Looking at the variables, they do not have any variables in common, which meant my GCF is a 1. So looking at this means that then all of this is going to go into my area model. So here is my area model. Same as we always have. The very first part goes in the first one, and then we're just going to walk on through. So walking on through. Now we have to try and find the GCF of the top. So 49 and a negative 21. 49 and 21 have the largest number of 7 in common. They do not have anything in common with x's. They do have in common with k's. They both have k squared. So 7k squared is going to be what this top row has in common. Now you're just going to go around and you're going to use multiplication for the rest. So 7 times a number is going to give me 49. So 7 times 7 is the 49. The k squared is already there. So the only thing that needs to come up here now is the x. So we will multiply 7 times 7 to get 49. X times k squared to get xk squared. Next one, 7 times something needs to give me a negative 21. 7 times a negative 3 would give me a negative 21. The k squared is already there. Now I just need the y to be there, so here is our y. So negative 3 times 7 is a negative 21. K squared times y is yk squared. So coming to the next, 7 times somebody has to give me 56. 7 times 8 gives me the 56. X times somebody needs to give me the xw, which means we need a w here. So 7 times 8 is 56. X times w is an xw. Negative 3 times 8 is a negative 24. Y times w is a yw. So we went ahead and found everything on the sides. So our final thing to do is to write the GCF, which was a 1. And now we have to put the 2 parentheses. So what we found on this side goes in this parenthesis, and what you found on this side goes in this parenthesis. So this is a 7k squared with a positive 8w. So 7k squared with a positive 8w. 7x with a negative 3y. So 7x with a minus 3y. This is not incorrect, but we usually don't write the GCF if it was a 1. So we're going to go ahead and rewrite it without the GCF of the 1. And this is our final answer, and we're done. So we're going to factor by grouping using the area model, and here is our problem. The very first thing we need to do is put it into standard form. Similar to the previous problem, we have multiple variables. So we have to consider the variables as a whole. So this has a weight of 2 because 1 plus 1 is 2. This has a weight of 2 because each of their exponents are 1 and 1 plus 1 is 2. So this has a weight of 3 and this also has a weight of 3. So the weights of 3, because they're bigger, should go first. But which one of these would actually go first? Because the n's both have the squareds, the c and the d determine it. Alphabetically, c goes first. So this is going to be a negative 7n squared c with a minus 6n squared d. They both have m's, which meant the c and the d determined, so he's first because he's alphabetically first, so plus 42mc, and this is a plus 36md. Now that's in standard form, we need to find if there's a GCF in common at all. So 4 parts meant 4 lists. The only way to get a negative is if you have a negative 1. 7 is prime, n squared and c. The only way to get a negative 1, 6 is 2 times 3. It's n squared and a d. 42 is 6 times 7. You have an m and a c. 36 is 6 times 6. So here's my 6 times my 6. You have your m and your d. So GCF, do I see any variables, letters, or any numbers in common? I see these 3 rows have a 3, but he does not, so 3 is not. And I see they have nothing in common, which meant my GCF is going to be a 1, which meant this entire thing is going to go into our area model. So something we need to do, yes, the GCF is a 1, but before we throw this into the area model, we don't like the leading coefficient to ever be a negative. We need it to be positive. So yes, I understand the GCF was a 1. We are actually going to still pull out a GCF. We're going to pull out a negative 1 so that this leading number isn't negative. Since we're pulling out a negative 1, that means the signs on all of these guys are going to change. So I have 7n squared to the third plus 6n squared d minus 42mc minus 36md. Now the reason why we did it, I understand we could not find the GCF looking at our lists. It's because they didn't have a GCF. The only reason why we pulled out a negative 1 is because we do not like the very first number being negative. So we had to pull it out. Now this is what we're going to put into the area model. So I have 7n squared c, and go ahead and walk on through. So now I need to find the GCF for the top. 7 and 6 do not have a number in common, so the highest number that they would have in common would be a 1. They both have an n squared. They have no other variables in common, so this is just a 1n squared, or just an n squared. So n squared times 7. So 1 times 7 gives me the 7. N squared times c is going to give me the n squared c. 1 times 6 will give me the 6. N squared times d is going to give me the n squared d. 6 times a negative 6 is going to give me the negative 36. D times m is going to give me the md. 7 times negative 6 is a negative 42. C times m is an mc. So we didn't find a GCF, but we had to pull out the negative 1 because we did not want the leading number to be negative. So I have a negative 1 that I had to claim that I pulled out, and now we got to figure out what our sides are. This side goes in this parenthesis, and this side is going to go in this parenthesis. We're not going to write 1n squared, because that is just the same thing as n squared, minus 6m. This is a 7c with a positive 6d, so 7c plus 6d. And this is our final answer, and we are done.